Algebra 2, welcome to lesson 3.4. This lesson I broke up into two parts. We're going to look at two different strategies to solve systems of three variable equations. Oh boy, these are just a blast. They're going to challenge you, okay? So be ready for it. And really, you're just going to have to do a lot of practice with these. I have lots of practice made up for you. And it's going to maybe not click the first time or the second or the third, maybe not even the fourth, but you get better, you practice, and you'll get through, okay? And if you're wondering about applications of these, we'll get into those a little bit later, but they are pretty applicable when you get into things like 3D modeling and you have things known as the X, Y, and the Z coordinate plane. Anyway, let's get into example 1. So solve each system by substitution. Okay, we can apply the same rules for substitution as we did with systems of two variables, simply by, if you have one equation solved for, okay, you can plug it in to the others. So I like to label my equations. There's triangle, there's circle, there's square. You can be as creative as you'd like. And what I'm going to do is, so x is solved for, I'm just going to substitute that into the other two equations. Now, it's all about being neat, so please be neat as you rewrite it. So this is triangle with x substituted. So I make that little thing there. So it's negative 5y minus z plus 23, okay, minus y minus 3z equals negative 9. So please note, this is just this plugged into this, okay? That's all it is. I'm going to simplify this amount, so it's very important with those parentheses to distribute negative 5y plus z minus 23 minus y minus 3z equals negative 9. And I'm going to continue to combine like terms. So y and y is negative 6y. Z, I got negative 2z. And I'm going to add my 23 over just so I have an expression that looks a little more comfortable, a little more like I'm used to. Negative 9 plus 23. If you don't already have calculators out, you can get those out. But that's simply 14. Okay. Being very careful here. I don't want to make any silly mistakes. Neither should you. So I'm going to hang on to this equation for later. Okay. We can actually label it star, perhaps. Something new. And the other thing I need to do is, well, circle with x in it. Okay. So I took care of this first equation. And what I have here now is z, okay, is equal to negative 3 times 5y minus z plus 23 minus 1, okay, and then begin to simplify. So z is equal to negative 15y, okay, plus 3z minus 69 and minus 1. Okay, I'm going to get it into a form I'm a little more comfortable with y and z on one side. So I'm going to add the 15y. So I have 15y. I'm going to subtract the 3z minus 2z. Okay, and then combining my like terms, I get equals negative 70. Okay, and this one I'll call diamond, and now with star and diamond, I can just use substitution or elimination again. So it's really just kind of a repeat of everything else. So negative 6y minus 2z equals 14, and then 15y minus 2z equals negative 70. In order to use elimination, if I multiply diamond by negative 1, it's going to change the signs. And then the y or the z's cancel. I get negative 21y is equal to 70 plus 14, 84. And if I divide by negative 21, I get, luckily, y is equal to negative 4. All that for y, which is equal to negative 4. Now, again, there's different ways you could go about this, but I just want to show you it that way. Now, y is negative 4. You still need to find x and z, okay? With y, you can then look back. What could I plug it into to find another variable? Well, if you have one variable, you'll have to plug it into an equation that has two. So I can take y now, and I could substitute it into maybe circle to find z. Okay, so doing that, it would be negative. Actually, I couldn't plug it into that because there's no z. Okay, to find the other variables, if you have one, you can plug it into an equation that has two variables. Now, specifically, you can use one of the ones I made. So 15y minus 2z will help me solve for z. So 15 times negative 4 minus 2 times z was negative 70, and that's negative 60, I believe, minus 2z is negative 70. I'm going to add the 60, of course, and hopefully this part is rather trivial for you. And z equals 5. So z is then 5, y we found is negative 4, and really you should be able to plug into any of the original equations at this point to find z, or to find x. So I'll use circle here. I already know that 5 then should be equal to negative 3 times x minus 1. Well, if I add 1, that's 6. And divide by negative 3, x equals negative 2. Okay, so that's just one way, substitution method, to look at a problem. Okay, let's take a look at another example. Okay, so another substitution type example here, and really just think of a way that you could go about and start plugging things in. So I see here, let's see, y in terms of x and z, y and z. Let's just try. Let's just substitute. Let's put x into y here. What that gives us then is y is equal to 5 times negative 4z minus 19. Okay, it could be very helpful to highlight things, that way you don't forget about anything, plus z minus 4. That's negative 20z minus 5 times 19 is 95, plus z minus 4, which means y is equal to negative 19z minus 99. And again, you have to end up using elimination or substitution usually at most points. So I'm then going to turn this into something I'm a little more comfortable with, adding the 19z over, and then I have y plus 19z equals negative 99. So what I did, I got it in the same format as this, negative 5y minus z, so that now I can use elimination or substitution. So negative 5y minus z equals 25. Elimination, let's multiply. I can multiply the top by 5. Okay, so that would make this 5y. 19 times 5, again, 95. And negative 99 times 5 is negative 495. Then I'll add, and things should cancel here. Okay, so the 5y and the negative 5y cancel. I have 94z is equal to negative 495 plus 25, negative 470, and divide by 94. And I get z is equal to negative 5. Nice. Okay, now with one variable, I can substitute it into something that has z and another variable. So I'm just actually going to work my way back, plug it in to find y. So I know that y then is equal to negative 19 times z minus 99. Y then is 95 minus 99. And then, I believe 19 times, yep. And then y is equal to negative 4. All right. Y and z are found. You can find x from the very beginning. Use that first equation. You could actually have already done that as well. And again, each problem's a little different, so you just have to trust your skills and just be very careful with certain operations. So 20 minus 19, and x equals 1. So 1, negative 4, and negative 5. Okay, so a little bit of a different problem, but all substitution being utilized there. Okay, so those are two good examples. I'm going to keep going through some other examples, okay, but that's the general idea. So feel free if you want to try out the practice problems, but there's a lot of practice here for you, so please use that to go through and try these problems out. Let's go ahead and do 3. Okay, and again, you might do it a little differently, but just try something and go from there. So let's see, y is x plus z plus 5, z is just 3y. Let's go ahead and let's go for it, plug y into z, why not? That makes z equal to negative 3 times x plus z plus 5. Okay, minus 3. That means z is equal to negative 3x minus 3z minus 15 minus 3. And negative 3x minus 3z minus 18 is equal to z. Let's get it into, let's see here, something we're a little more comfortable. So this has terms of 2x and y, and now we have x and z. So that's going to be a little difficult for us there, but that's okay. We'll still work with something here. So I know that z then, if I subtract the 3 over, or add the 3z, I know that 4z plus 3x is equal to negative 18. Now, I wanted to show you this because I get to this point here, and at this point, I'm kind of stuck because if I want to use this third equation, this has terms of x and y, and this has terms of z and x. Okay, so as you start these, you might make a step that really doesn't help you out at the end. Okay, so maybe you try something else. Or you just kind of go from here and think, how could I substitute that now into the other equation? So that might have actually been a misstep, so to speak. But really, you just learn from it and you keep going. What I could possibly do now is reverse substitute. Let's put z, and I know that's there. So I could also do 4 now times negative 3y minus 3 plus 3x equals negative 18. That's negative 12y minus 12 plus 3x equals negative 18. And what that comes out to be, negative 12y plus 3x equals 6. Negative 6 if I add 12. So I'm almost there. Now I have y and x, and I have y and x. I'm just going to rearrange this. Whoop. So it's 3x minus 12y equals negative 6. And then, if you have two of the same variables, you can use substitution or elimination. So let's see how this will turn out. 2x minus y equals negative 4. What else do we have? 3x minus 12y equals negative 6. Let's use substitution or elimination. I'm going to multiply the top by positive or negative 12. Okay, that will get me negative 24x plus 12y is equal to 48. That's just there. And we'll shake and bake, so negative 21x, 12's cancel, equals 48 minus 6, 42. And looking like it's going to come out pretty nice. So x equals negative 2. Nice. So again, try and match things up. If you misstep the first time, think what you could possibly do to fix it. So x is negative 2. Let's find y. So I could use really my previous equation. I'll use the 3x minus 12y equals 6 equation. So y, if I just plug it in here. So I know the work is all over the place, but you know, the end of the story is you'll get there somehow or another. So negative 6 minus 12y equals negative 6. I'm going to add 6. Negative 12y is equal to 0. And that just means y equals 0. And then to find z, I could use the green equation. Negative 3 times 0 is just 0. So it must be negative 3. All right, so another bit of a challenge for you. Hopefully you got that one. And again, great job. Try these. Just keep trying. Just keep practicing. And the answers for you should be at the bottom of the page. So please go back, check through your answers, especially for these. And they should be listed for you at the bottom. So lots of examples. I'll get some work up there for you. But really, there's different ways to go through all these. So I would at least try some of the odds and check your work. Check your work. Great job.